Last week we talked about why you need a message queue, the shock absorber, for your integrations. Today we build it. We're going to build one of the most important patterns in ERP architecture, the fire and forget. Here's a scenario. A user releases a sales order in Business Central. We need to send that order to the warehouse management system or a third party. We need to send that order to a warehouse management system. The wrong way. You write AL code that calls the warehouse API directly. The user clicks release, the screen freezes. It waits and waits. If the warehouse is down, error. User can't release the order. Business stops. The right way. Today's video. User clicks release. BC sends a quick message to Azure. Order 1001 is ready. BC returns the control to the user instantly. Azure catches that message, puts it in a queue, and processes it reliably in the background. If the warehouse is down, the message waits in the queue. No error for the user, no lost data. This is week 6 of our roadmap. Let's build it. So if we look at what we are building, it's a 3-step flow. First, we got the trigger. You trigger in BC an AL event subscriber detects the order release. It sends a JSON packet to the Azure function. The ingest, the Azure function 1. This function receives the HTTP request and puts the message onto the service bus queue. It does not process the order. It saves it. It's fast. 3. The processor, Azure function number 2. This function triggers when a new message hits its queue. It picks it up and sends it to the warehouse system. But wait, Dennis, why 2 functions? Why not just have BC talk to Service Bus directly? Well, there are 2 reasons for that. The first, security. Talking to the Service Bus directly from AL requires managing complex SAS tokens or identity. Calling a HTTP function is standard, simple, and we can secure it easily. Number 2, decoupling. The ingest function is a generic door. Today it puts data on a queue. Tomorrow it could write to a data lake. BC doesn't care. BC just knocks on the door. Let's start with the Azure side. Now last time we actually built all of this. Remember we have our place order, which is just a HTTP trigger, and then we got our process order, which is a service bus trigger. So all we actually need to do is actually create the Business Central code that will call this place order, and then our service bus will process it. Now we just need to change what the payload that we're going to send to this process order is going to be. Because remember, before it was taking an order ID, a customer name, and then the lines in a JSON object. Now we just want to change it so it takes an order number and a customer. An order number is of course going to be the sales header number, and the customer, let's say that's the sales sell to customer name. So let's go back to our Visual Studio Code and let's use our Copilot. So this is our function, as you can see, and this is the function we want to change. So let's make Copilot do that. So let's first tell it what pages to look at, and it's our place order here. And let's say change the JSON payload to accept a order no and a customer. So now it's changed. It takes an order no, it takes a customer, and it takes lines. Now it shouldn't take lines, and we really didn't want it to take name, email. So let's get rid of that. So let's just make it should only take a payload, and let's just write the payload so it knows what we're talking about. nothing else. So let's say it should only take payload, order no, customer, nothing else. So let's see what it's done. It's changed our ID to no, says it has to be required. Our message ID is going to be our order number. And our customer down here is a string. Let's try to keep that. And let's tell it to give us a sample payload. And it's given us a sample payload. So let's try to run this locally first. Now, as you can see, we actually have some errors on our process order because that expects something else. So if we try to go here to problems and you see they have all these. So let's just take these and see if our AI can fix it for us. It says that it fixed them, so let's try to run it. And it should be running. And we are on port 7071. Let's again try to take our payload here. This is still on 7071. Let's change our payload and send it. It has given us a 200. Over here, everything looks fine. Let's go to our Azure and let's go to our Service Bus. And let's go to our orders. And to our Service Bus Explorer. And maybe we are too slow, so maybe it has already been picked up. It seems like it. Anyway, there's no message here. So let's go over here and see if process order it has already picked it up. So now that seems to work still, right? Perfect. Now it's time to actually hook this up to our Business Central. So again, let's go back. The one we're going to be, actually first we need to deploy it, right? So let's just disconnect this. And let's deploy our function and deploy. And it has been deployed. So let's go back to our Azure functions, go to our place orders, and we're going to need our HTTP endpoint, right? So get function URL. Let's go with our default and let's create the Business Central code. So over here, let's just change our AI model. And let's just use Sonnet again. So what I'm telling it is create an event subscriber to code unit release sales document on after release sales stock that calls the following endpoint, so as a function with the payload like that. So let's see if it knows how to do this. Okay, so it's created a new code unit. Let's see what it has created. So our endpoint, our payload. Yeah, let's just see if that works. So keep. Now, of course, a good thing is always to do this, right? So if sales header is temporary, then exit. Because if it's temporary, we don't really want to send anything. So let's just do that. And let's deploy it. And it's deployed. So let's go to our sales order, see if we have any. Let's just take the first one. And let's try to release it. It has been released. And as you can see, it has been triggered. And just to say, place order. We're not really logging anything about our order, but this is our order. And if we go over to our process order, we can see that it has also picked it up from our Service Bus. So perfect. So Business Central is now sending data to our Service Bus. So now there's always the what if scenario, right? Now imagine the process function is crashing. I release the order, BC still stays released. Instantly the user is happy. Azure tries to process, fails, waits, tries again, fails, moves to dead letter queue. The user work is never blocked. We, the developers, can look at the dead letter queue, later fix the bug and replay the message. This is resilient architecture. Okay, so let's try to make this fail. So let's try to say if our Copilot here can do something with it. So it is going to be our process order. Let's say we need to test the dead letter queue. Can you make this fail? So what has it done? Here it throws an exception right here for testing. Try to build, see if it can compile. It can compile, so let's deploy it. It has deployed it. Let's go to our Business Central. Let's take a new order. Let's take this one. Try to release it. Business Central says it has been released. We have triggered it over here. So that should be fine. So if we look, this hasn't yet been updated right on the process order. However, if we go over here, you can see we have something in our dead letter queue. And that is indeed our message. And then we can of course go in and see what has happened. It's the reason why it is hinted here is because it tried to deliver this message the 10 times that we asked it to, and it got an error response on all of them. So it could not be consumed. And then we can go down here and see, okay, what was the message? And then we can try to debug and figure out why this couldn't be processed. And that's how the dead letter queue actually works. No lost messages. This pattern, BC function to service bus to function, is the backbone of enterprise integrations. It scales, it handles failures, it keeps BC fast. Your homework for week 6. Create an ingest function, HTTP trigger. Create a processor function, service bus trigger. Write AL code to call the ingest function when a customer is modified. Easier than sales order if you want a quick test. Modify customer in BC and watch the log in Azure. Next week, we're going to look at logic apps. Sometimes you don't want to write C# code for the processor. Sometimes you just want to drag and drop a connector to send an email or update SharePoint. We'll see how logic app fits into this picture. See you in week 7.